Hello, hello. Yeah, okay. So I think we are live. Let me check once. Yeah, okay. So yesterday we solved four questions, I believe, on the live stream, and I was solving questions from this list. So I'm continuing on this. Yeah, yesterday we solved till decode viz. I solved trapping rainwater today at 5 p.m. So now I'll continue with this list on Leetcode. Let me just search the question. First, any character in the string. Okay, first unique character in a string. Okay, this is an easy problem. Given a string, find the first non-repeating character in it and return its index. First non-repeating character basically. So L does not repeat here, so that is the first non-repeating character, and we are returning its index. Here L is repeating character, O is also repeating, B is not a repeating character, so that is what we are returning, and we have a minus 1. Okay, first non-repeating character. First non-repeating character. So, like, there are multiple ways to do it using frequency array and stuff. We also need to, okay, one easiest way which I can think of is a frequency array. So we can have a frequency array which will store frequency of each of the alphabets. Yeah. So we'll iterate through the string, and current character is called s dot char I, and we will go to frequency and update the corresponding index. Okay. So when we initialize, it is automatically filled with zeros, and we are filling up the indexes. Now, since I have to find the first non-repeating character, what I can do is I can again iterate over the string, and I can check if frequency of, wait, I need the same stuff. If frequency of this is equal to 1. Exactly. This is what we want. And as soon as we find the first character which matches this, I can return the index value. If we don't find any character like so, we'll just return -1. So here we are using a constant space, and obviously TC is open. This will get submitted, but I think there is some better approach to it. So, hmm, what is a better approach? Let us look at it. Like, can we do it without the frequency array? Do we have some forwards for this? Topic has house table, hash table. Sorry, discussion. Uh, Oh, interesting. This is really interesting. So do first and optimize this editorial linear time solution. So yeah, they're using hash map. This is, so yeah, I think. this is the most optimal solution. We are also using this. Yeah, okay. So, okay, let's move to the second question. This was an easy question. Anyways, let's move to the second question. Next question is ask this one. Median of two sorted arrays. Let's take this one. I think this is tagged hard or we could median of two, median of two sorted array. Yes. Yeah, it is tagged hard. So given two sorted arrays of size m and n respectively, return the median of two sorted arrays. So we have two sorted arrays. Median would be merged array is this and median is this. Okay. Merged array is this and median is this. Okay. Okay, okay, okay. So do we have any expected time complexity is yeah 2 of log n plus n. Of log n plus n. Okay. Hmm. Uh, sorted arrays of log n plus n. So, like the brute force is, of course, merging the two arrays. We can simply merge it, and then we can find out the median, which would be an O of n plus n solution. Okay, like we can have two pointers, one at this position, one for nulls one, one for nulls two. We can compare and keep on incrementing and create a merged array, and then in the merged array, we can simply calculate the median, which is the simplest solution or the brute force solution. Other than that, so I'm not implementing the brute force. Other than that, what we can do is we have two arrays like this. Now then, should I code the brute force first? Maybe it gives me some idea about improving the performance. We can try implementing the brute force. Wait, we have this median is basically 4 by median is this. Okay, median is the this middlemost. Median is yeah. Median is the middle element. They should have given more spaces. Uh, okay, let's implement the brute force which is coming to my mind because I'm unable to think anything better than that. So, yeah, okay. So I'll implement the brute force. So the is brute force is we have yeah. So brute force is to merge, right? So let me just create a merged array of size n plus n. We will have two pointers. Uh, we'll have I equal to 0, j equal to 0, while I less than n and then j less than n. Yeah, what we have to do is we have to compare if nums of 1, if nums 1 of I is less, whoever is less will be added to the merged array. So I need a pointer for merged array as well. So that pointer be this. So merged of k would be equal to nums 1 of I, and we have to increment both k and I. So yeah, else same stuff but with g and nums of 2. Okay, so after this, if you know, it might be that one of the arrays is sorted. Like in here, we'll exhaust all the i's. So this first if condition first condition will become true and will become false and we'll move out of the while loop. So what we have to do is we have to take care that if I is still like we have to take care if j and I have not reached the end position, we need to just copy paste all the remaining elements. So we can do it like this, and I think we can also just add plus plus here. So yeah, same thing for j. Sorry. Okay. So yeah, the system now. The system uh, now we have a merged array. Okay, we have a merged array, and we need to simply find the median. So now it is a very easy question because whatever array I have, I just need to figure out the median. So we have n plus n, length will be n plus n. So if it is odd, wait, median length is merged to dot length. Now if median length is 2 is equal to 1, if it is odd, if we have like 3 elements in the array, what is the result? Double result is equal to what I'm going to understand median is the average or the centermost element. Okay, so if it is odd length, then it would be the middle element. If it is even length, then it would be the average of two middle elements. So if it is odd, we need the centermost element. So length is 3, centermost element index is 1, so just 3 by 2. So we can simply do median length divided by 2. We have to pick this index. Yeah, okay, and we can return the rest. If it is not equal, if it is an even array, if we have something like 1, 2, 3, 4, then we have to find the we have to basically find the average of these. So here summation will be sorry n is 4, n is basically length of this is 4. So what we have to do is 0, 1, 2. So to pick the 1 as an index, which means we have to pick the indexes uh, n by 2 is 2. So we have to put 1 and 2. Okay. So merged of length by 2 equals 2 and the same thing uh, minus 1. Yeah, we just add these and then result would be sum divided by 2. That's it. And we return sum. Sorry, we return this. I is equal to I is equal to 0. What is it? What is the issue? 2.5, 2.0. Summation is firstly 5, 5 by 2. I don't know. Should I make it double? Yeah. So its time complexity is we are iterating through both of the arrays, which is like O of m plus n, and this, these are all constant time space. So O of m plus n. Now time complexity is not really high, but of course there is a better approach to it, and obviously the runtime complexity expected is O of log m plus n. So yeah, let's try to optimize it. Okay. I have anyway submitted the solution to figure out if we are correct. Yeah, we are good with our logic, but we need to improve the logic. So how to improve the logic? Discussion. Discussion section. I usually get some good hints which are really helpful. In an interview last week, I am a favor because of my manager. Oh, really? No one has actually given the solution in log of n plus n time. I mean, like, there are no hints in the discussion section. Do we have a little tutorial for this? Yes, we have. Okay. Merge sort is what we did. Uh, yeah, so 10% and walking. Okay. So approach 2 is binary search because the inputs are sorted arrays and the problem asks for level 2 variables from a field that is a balancing method. Think that is a normal research. This was instruction for binary search. Okay. Binary search to find a find target. Sorted array. Okay. This is regular binary search which they are sharing. Was there left is specifically PF5 as shown in the picture below? I don't know. They have written this too many things. I don't want to go through all of these. I just want one small hint which helps me to figure out an optimal solution to it. Hmm. Median of hmm. Okay, so I think the approach, the intuitive, the optimal approach is not very intuitive. So for now, I'll just note it down. We'll go through it maybe sometime later. So I'll not mark it as red. I'll mark it as sorry. I'll not mark it as green. I'll mark it as red, red, so that I can go through it some other day. Here also I'll add a note of it. Median of two sorted arrays. But I don't know. This question has been asked in so many interviews. It can be asked in any interview. I should have better prepared this one. Binary search. It's definitely a hard. Hmm. Okay. Let's move on to next question. Implement hash. Okay. This is a good question. Find the next number of permutation. This is also a good question. Let's solve this one. Find the next number of permutation. Next permutation. I think I've solved this one before. Yeah, solved this one. So a permutation of an array. Let me just share this also. Right now we are solving next permutation. Solving 41 next permutation. So just to tell you that all of these questions have been asked in Goldman Sachs. Like this is a list I'm following. Uh, so these are all Goldman Sachs questions. They have been asked in coder pad round. That is why. So yeah, okay. Next permutation. A permutation of an array of integers with an integer. Yeah, yeah. 1, 2, 3. Then we have 1, 2, 1, 3, 2. Then we have 2, 1, 3. 2, 3, 1, 2, 1, 2. Yeah, this is good. Next permutation is the next lexicographical data permutation. Formally it is yeah, okay, okay, okay. So replacement must be in place and use only constant external memory. Okay, ठीक है. So whatever we have been given certain digits and we need to figure out the next permutation. ठीक है, चलो. Let's try to figure this out. We have 1, 2, 3. We have 1, 2, 3. 2, 2, 2, 2, 2. So if I try to write permutations, how do we write? How do we write the permutation? We have 1, 2, 3. We first try to from 1 to 2. What should be 1 to 2? Then we can have okay, okay, okay. Yes. If it is basically we have one sequentially. Now one is inverted. Basically we can only have these two combinations with one. So now we use two. In here if you see we have two, we have three. Basically we are starting with two, then we are going to one, then three. Now two, now we cannot have two, we will have three, one. Now three, we cannot have yeah we can have one, two, and then we have three, two, one. So this follows the sequence. We have one, one, basically one, one, two, two, three, three. Here we have two, three, one, two, one, two. Okay, 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 okay. I think this is an ad hoc. I mean, this can be simply done to figure out some test cases. So let me just try this out on a pen paper and then I'll code it up. Let me check once. So I have been given, so suppose I have been given 3 to 1. Let's see. Or suppose I have been given 1. Yeah, okay, let's take 3 to 1 example. We have 3 to 1. So whenever, suppose I am at this and I want to figure out this. Hmm. 3 to 1, 3 to 1. So the last one is completely sorted in a descending order, and this one is sorted in an ascending order. Okay. Um, so when I move to this, what we do is there are 3 to 1, 1 to 3. Hmm. Okay, so next permutation. Okay, if we think about it, basically we are okay. If we take it as a number, okay, this is 1 to 2, and then this is 1 3 2, which is the next bigger number we can form via these three digits. So if we had a dictionary where we just had these three digits, then after 1 2 3, we will find 1 3 2. Okay, okay, yeah. So this is one important thing. Hmm. From 1 to 3, we have to reach to 1 3 2. Then the next number in the dictionary will be 2 1 3. So we are taking the smallest number in the front. Yeah, that is the core idea. The smaller numbers should be at the beginning. As we move through the permutation, greater numbers will start coming up. Okay, so since I have to move to just next bigger number, if I see 2 is less than 3, okay, here we have 2 less than 3. We are saying we can rotate this index or we can convert this index, swap this index and make it 1 3 2. Okay, let me take another example so that I am able to figure out a logic which will help me implement it. Okay, let's have something like 1 2 5 4 3. Okay, we start from this. Logically, if I just logically think and try to figure out the solution, um, the next figure element is uh, 1, 2, 5, 4 is done. So here, basically, okay, yeah, okay. See, if you see here, if you try to think of the next permutation for this, we have 5 here. Okay, this means like we have done all the counting till 12,500. Let's talk it like let's say it like that. We have done all the counting till 12,543. What is the next bigger number? We will we, we will have to update this. Correct? We'll have to update this too. This is the logic. We'll have to update this to move to figure out the next permutation, which means we have to find first decrease from right, like from 3 to 4 increase, 4 to 5 increase, 5 to 2 decreasing. So 5 to 2 is decreasing, so that 2 index becomes a index. Like that is something we need to mark. Index 2. Sorry, this is index is 1, the number is 2, which is the decreasing first decrease from right, and we have to just increment that. So now next, what we have after 2, we have 3 in the given set of numbers, right? So now we have 3. And okay, where is 3 in the given? In 3 is at, so 0 1 2 3 4. So next bigger 3 at index 4. Okay, so what is the next number? The next number would be, have this. Basically, if I just bring out the 3 and swap it with the index, current index, this is this, but the number should be 1 3 2 4 5. So we have to reverse the stuff after this index. So this reverse. Let's take another example. Uh, let's take 115. See, if we are repeating now, you won't be able to understand. So let's take another example, which is 5612. Yeah, 5632. Let's take this example and let's try to follow this. First, decrease from right. 2 to 3 increase. 3 to 6 increase. 6 to 5 decrease. So we have found the decrease. So index 0, there is a decrease. What is the next number? Next bigger number. Next bigger number is 6. Next bigger number is 6, which is at index 4. Sorry, sorry, index 1. Next bigger 6 is present. So we swap 6 and 5 if we do. And then, yeah, yeah. Here we don't have any number between this and this swap. That is why we don't have to do any uh, reverse. Okay. So yeah, okay. I think this is good. This will work fine. Let me try to code it out and verify the solution. Hmm. Okay. So since we have to find the first decrease from right, let's just start our iteration from right hand side. And while this is 0 greater than 0 and is greater than equal to, yeah, okay. So we should start from 2. We will keep on doing I minus minus. Okay. Yeah, okay. Then uh, we have to figure out the next bigger element. Okay. So yeah, next bigger element. Let's just try to figure out the next bigger element. Basically, we are getting, suppose we have received two as this representative, we have to find the next lower element. So j is at this last index, okay, and we're just trying to figure out if it is greater element, if it is lesser than it, then we are decrementing, otherwise yeah. And then we swap I, okay, and yeah, and then we have to reverse the numbers in between these indexes, in between these indices. Let me just write it out. You can have this. Then let me also reverse. Should we reverse? Should we write a different function, or we can add the logic here itself? Let's add the logic here itself. Sorry. Yeah, let's add the logic here itself. While we are trying to reverse. Uh, oh, wait. Let me do one thing. Yeah, this will be easier to understand. Hmm. Devansh, if we use the inbuilt function, what is the use of this BSC version? We cannot use the inbuilt function in an interview, right? We cannot use inbuilt function in our interview. Hmm. What is the issue? Okay. Array, I'm also not returning. Do I have to return? No, I don't have to return. Okay, that is why we are doing this in place. Cannot find support. Yeah. Index out of bounds for length 3. Index -1. Let me remove all of this. So there may be a scenario where the array is like in its last conversion. So at that time, this will come up as -1. Most of them cannot find symbol. Okay, my bad. That is an interesting question. I mean, you should explain that you know about it and then they will tell you to solve it out using random questions. Okay, 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 bro. ठीक है. But this is an interesting question. Next permutation. Let's just note it down. It's done. But it is basic arrays. It is hard, I would say, or of medium complexity, but logic is logic building or just plain logic building. Wait, we are picking up the next question in a minute. So next question would be we can solve any of these. Okay, let's see if we have lead code most frequent word. Yeah, okay. So let's solve this one. Most common word. This is this is lead code 818. Okay, it is an easy question, but I have not solved it before. Hmm. What is the question? Given a string paragraph. Okay, this is a paragraph. And a string array of the band words band return the most frequent word that is not banned. Return the most as a most frequent word. So word which is occurring a lot number of times, but it is not banned. It is guaranteed there is at least one word that is not banned, and that the answer is unique. Okay. Our case insensitive, and the answer should be returned in lowercase. Okay, that's good for us actually. So we just need to find most frequent word, and it should not be banned. Should not be banned. And words cannot contain punctuation. Okay, so we can ignore all the punctuation, all the case stuff and everything. Okay, okay. So one thing is obvious: if we are going with case insensitive thing, then we can just convert our uh, given string to work with, so that it is easier for us also. Other than that, so if I have this something like this, we can uh, we can create an array of the words. So like we will have something like Bob hit ball, the hit ball. So we can have some array called words array with all the words, and yeah, we can just calculate the frequency and then it should be easy. So it's I think this is simple implementation. You cannot hear me? Hello. Yes, my mic is connected, and I think audio is working. Let me find it. May be little low though. But I'm not saying anything what value, so even if you're not hearing me, it is fine. Yeah, okay. So let's just first create our paragraph. So simply I'm just changing paragraph to lower case. Okay, and I am creating words. So we can just create. Okay, I also need to take care of punctuation correctly. So what are punctuation symbols can I expect? Can I expect? Okay, there is no list of punctuation symbols. It means I should take care that I am only picking up the lowercase, basically the character values with from A to Z. Okay, so let's do one thing. Let's do one thing. Let's do one thing. So I have two options. Like there may be some inbuilt function which will help us replace all the punctuations. But what I can do is I can iterate through the paragraph. How long is paragraph? Okay, yeah, we can easily iterate through the paragraph and just pick up the stuff which is, you know, um, string builder, SP, new string builder. So what I'll do is I'll iterate to, to yeah, to the paragraph dot length I plus plus and then and then once we iterate, I'll remove all the punctuation, which means I'll just pick up the stuff. So I'll say uh, if paragraph, let me just copy this, it's too long about paragraph dot char at I is equal to, if it is a space, or or if the stuff char at I is greater than equal to A, and then it is less than equal to Z. Yeah, only then we can do append. We can append the this char. Let me just write it in a cleaner way. Yeah, okay. So this is much cleaner, and we are appending the current here. After this, we can perform the lowercase stuff on SP to string and to lowercase. Yeah, so now it is fine. Now we can do this words thing, the split thing. Now I can just create a we can see as map string word in words. Okay, yeah. One more thing is I should only calculate if it is not a banned word. So now I can add all the banned words in another set for easier calculation. Let's do that. And set would be, and then I can do string B in band set dot add the word. Okay, and yeah, here we can just add a check if not banned set dot has, if not banned set dot contains has is in JavaScript. I often confuse the APIs between Java and JavaScript. So if it does not contain word, then we can add it. But for default plus one, yeah. So now we just have to return the result. Let me just count max frequency for var entry in dot entry set. If entry dot get value, if it is greater than the max frequency, then max frequency is equal to the value, and our result would become the return. This is simple ad hoc. That's what I think. Let's see. Let's see. What is the issue? Output is the expected was small. Okay. Output is A. Yes, A. Why did I output the occurrence of the is once and ball is multiple times? Have I done something wrong? Frequency, string result, max frequency, exactly dot this frequency dot empty set. Um, let's let's log get, get value. Where is the issue? If not, it contains words, then we are adding. We have a band set. Here we are removing all the extra stuff. Then that is converting to lowercase. Yeah, okay. Guys, empty string is also coming. Empty string should not come up in our frequency map. I don't know why from where the empty string is coming. Entry the, okay, yeah, entry is the value is one. Ball. Okay, for every word, value is one only. Why? Frequency dot get or default word comma 0 plus 1. This is correct. Are we not? Okay, let me output folder this. In C plus plus, C out is really nice. It is way shorter. So yeah, let me just see out the word. OB, hit a word of it. Okay, okay, wait. Acha, okay, I'm doing it to lowercase later, but here I'm only taking care of this. Okay, my bad. I should change it to this. Wait, let me copy it. Let me paste it. So I'll do this stuff. Sorry, I'll do this stuff on P. Okay, on P. And P, I'll say P is paragraph dot lowercase. Okay, after this, I'll just do sb dot useful. Yeah, now it should be good, I think. I know it is taking too much time to spend P is already defined. Array, P2, P2. Yeah. Hmm. This is a good mental exercise, good revision of all the APIs. What is AR? We failed one test case, one on 49. What is the issue? A, BBC, C, band A. How to see expectantly. What is wrong with my solution? Let me check. I am failing this test case. I have to use this test case. Okay, okay. So this one, this, this is a terrible test case. It is getting changed to BBB after my logic. Or something like A, yes, yes. And then it becomes B, B, C, C. While it should have been B, B, B. Okay. Hmm. What is the issue? Okay, here. So it is greater than equal to this and less than equal to this. Then we are appending this. Okay, in place of any punctuation, we need to add a space. Okay, okay. Hmm. Yeah, okay. It will get submitted now. Hmm. So most frequent word is done gas station. Now solving gas station. Acha, let me note down the problem. I think I have solved this question a few days back. I think. Let me see. No, I have not solved it. I have never solved it. But I have solved it. submissions 2022. Okay. There are n gas stations along a circular route where the amount of gas is it now. Hmm. Okay. You have a car with an unlimited gas tank and it cost of I gas to travel from IFS station to the next dismounted station. Okay. Then it ends with an empty tank and to another you include liters gas and cost from the starting gas station's index if you can travel around the circuit once in a clockwise direction. What do I have to do? Wait. I have to you have to figure the sample okay, given to integer arrays gas and cost whatever the starting gas station's index if you can travel around the circuit once in the clockwise direction otherwise you can minus one. Okay, so it is a circular route which means you can start at any point and we just want to cover all the points 1 2 3 4 5 cost is 3 4 5 1 2. Basically this is telling me how much gas I can fill at station I, and this is telling me how much gas I need to travel from ith station to its next I plus 1 station. Basically, if I have to travel from I0 to I1, I need three units. I1 to I2, 4. Similarly, if I have to I01, 0, 1, 2, 3, 4. So I4 to I0, it would be 2 units. Okay. Starting station index to complete a circular route. Okay. Start at, if I start at this index itself, I need 3 units, but I will not have 3 units, right? Okay, right. Okay. I, no answer here is given as 3. So we are saying start at index 3. So start at 0, 1, 2, 3. This index. Okay. Fill up with 4 units. So if we start at this index, we'll have 4 units of gas. And then we can travel to the next station. At the next station, turn, we need 1 unit, right? So 4 minus 1, 3 is pending. And at the next station, I get 5 more. So 8. Okay. Then I travel to the next index. So 8 minus 1. Basically, this would be added and this cost will be minus and gas will be added. Okay. Okay. So maximum gas I can fill is 10. Sorry, 20. 5, 6, 7, 15. Yeah, total. And total cost of filling gas is again multiplied by 15. So it is possible. In this question, if we see, maximum total gas required, gas I can fill, or like the max capacity of gas I have is 9. But total cost basically means the minimum number of gas units I need is, this is 9, this is 7, this is 10. That is why here we have to return -1. Okay, here or here. ठीक है. So total gas available is 9, but minimum gas required is minimum required is 10. So we return -1. That is one part. Another is, okay, suppose if I started, I'm starting on the first index itself. I am at the first index, okay. So in what happens for my tank, I get this index, I get this as gas, and I have to utilize, or I use up this amount of gas units. So yeah, this is the equation for any particular index. Okay. Do you know why Bool takes 4 bytes of memory just for true and false? Bool takes 1 byte, right? Bool takes up 1 byte. Okay, where were we? Are where were we? Okay, yes. Tank plus equal to, this is the basic formula for any index. I think we can just go through and figure out this solution. Which means, let me just uh, try solving it. So we have total gas, we have total cost. We'll iterate, uh, and total gas plus equal to cost of I, total cost plus equal to cost of I. So if total gas is less than total cost, we can just return -1. Else I need to find a resultant index, and this is our capacity of tank, or our quantity or current gas presence in any in our tank. So we are trying to measure that by this tank variable. I should be less than n, I plus plus. So here tank will have this minus this. Yeah. So suppose I'm starting with this. I'm saying tank will have 1, basically 0 plus 1, 1 minus 3 minus 2. So it is negative. If it is negative, it means we cannot start at this index. So let's try starting at the next index, and we will reset our time. Start. So yeah, if you try, like basically, ultimately we'll figure out the index. So basically, if you try run, for the first we won't be able to do, we will come at 1. Uh, so 0 plus 2, 2 minus 4, again negative, we cannot start, so we move to the next index. 0 plus 3, 3 minus 5, we cannot start, again we move to the next index. 0 plus 4, 4 minus 1, 3, that is positive, we don't enter this loop, we move ahead. So right now our tank has capacity 3, okay, and then we, okay. So here it says that if there exists a solution, it is guaranteed to be unique, okay. So now we move on to 5, and again we add on, and it's 10. So yeah, I think, uh, let me check. Why does it take 1 byte just for true and false? Because 1 byte is equal to 8 bit, while only 1 bit is required to represent true or false. So I'm not sure if you have read, if you uh, have ever studied this, what is it, um, COA, Computer Organization Architecture. CPU works with words or word blocks, as far as I remember. So the CPU will not work with 1 bit or stuff like that. Uh, yeah, I think we call it word only. So CPU has words in it. Okay. Uh, so yeah, and minimum like minimum addressable unit for CPU would be 1 byte. That's why CPU does not work on one single computer organization and architecture. So CPU works with words. CPU can't address single bits efficiently. Okay, let's move ahead. Have I submitted? No, I'm not submitted. Let me submit. Let's go through the comment discussion section. We may find something interesting. The interview in a couple of hours will lead to shooting your important discussion, but you can be starting this from any session between 2019. If it does not have any solution, please just assume the guest content for you where computer loops are not can encode the indexed version because all computer loops can break as well as okay. This is a good approach. It's a very intuitive approach as well that you just start at any index and keep a track of when the gas is falling negative with the lowest amount, and then you try to start from that index and move to all the indexes. So it is a pretty intuitive approach. People may use it. I genuinely want to know what it is that found trying to test that and put this more and be better at it. Last sentence is there. Once you subtract cost array from gas array, it becomes maximum sub array problem. This is a very interesting take. Once you subtract cost array from gas array, cost array from gas array. So gas is 1, 2, 3, 4, 5, and if you subtract this, so it is minus 2, 2 minus 1 minus 2. Cost array from gas array. So 3 minus 1. Cost array from, so 1 minus 3. Minus 2, 2 minus 4, minus 2, 3 minus 5, minus 2, 4 minus 1, 3, 5 minus 2, 3. Cadence algorithm. Cadence algorithm is to find the maximum sum sub array. Sum sub array. Here we are returning the starting gases index. How is it your maximum sum sub array starts from this? Okay, in the hint section it is mentioned that it is cadence. No, it is not. Solutions. Easy solution. It are complete. Given the solution, so starting point exists. To find that quantity graph of this, let me say that is yeah, this is what we followed. This is what we followed. Okay, I think that's good. Let's move on to the next question. Longest increasing subsequence. Okay, I'll be back in a minute. Will be back in a minute. Okay, I am back. I'm back. I'm back. I'm back. Uh, I am back. What is the question? Longest increasing subsequence. I think I've done this question 1000 times. Given an integer array nouns, return the length of the longest strictly increasing subsequence. Strictly increasing subsequence. Okay. Here the length is 0, 1, 2, 3. Okay. Let's take this example only. Okay. Longest increasing subsequence. Okay. So we are at, we have received this input. Okay. This is the input we have received. So if you see uh, from 0, okay, we have 0, from 0 we can go to 1, then we can go to 2, and then we can go to 3. So this is the longest increasing subsequence. Okay, now how to figure this out? How to figure this? Uh, 0, 1, 2, 3. So, okay. Uh, hmm. Basically, uh, suppose for the first index, length of longest increasing subsequence or length of longest increasing subsequence for any index would be 1. Okay. Okay. Now what we are checking is 1 is greater than 0. Okay. This is greater than 0. So it can contribute to the LIS. So for the previous one, whatever the previous one value is, we try to take it and increment it with 1, and we can make it 2. Okay. For I equal to 0. Okay. Now when I'm here, I am looking at the ones before it. Okay. So now when I come at this 0, I look at the stuff before it. Before this, I have a 1 and I have a 0. Now, strictly longest increasing, we have been told strictly longest increasing. So neither is 0. Okay, this I've added wrong. Okay. It is 0 should be less than 1. Let me just check it. Now when I add this 0, neither is 0 less than 0, nor is 1 less than 0. So we don't do anything. We move ahead. We come at 3. For 3, again we check all the indices starting from this first index. 0 is less than 3. Yes. So it can contribute. So right now its value is 1. It can contribute, which means it will add to its length. So what we can have is we can have 1 plus 1, whatever is present for this 0 plus 1. Okay, and that can come up here. So we can have 2 here. Now 1 is less than 3. This means this one also can contribute. This means whatever was here plus 1 can come up here. And we also have to see it should be maximum. Okay, so plus 1. So here we are coming with 3. So we have here 3. Now 0, it also can contribute. Okay, but when it contributes, it will become 1 plus 1, 2. We already have figured out a subsequence of length 3. So we will not update it. Okay, so it will stay at 3. Now when I come at 2, again we start from 0. So 0, 2, we can update. So it will become 2. Then 1, 2, again we can update. It will become 3. 0, 2, we can update. But 1 plus 1, 2. No need to make this change. 3, 2, we cannot do anything. Let's come at 3. Then we come at 3. Again start from 0. 1 plus 1, 2. We can update. We can come to 1. Again we can update. Then 0, we can update. But 1 plus 1, 2 is less than 3. So we do not update. 3, uh, we cannot, it should be less than, strictly less than 2 less than 3, yes. And here 3 plus 1, 4. So we should update, and we update and we get this. So yeah, this is this would be an O of n square solution. What is the O of n square solution? O of n square solution, correct. So let's just write the O of n square solution. For and equal to for this I can start from the first index, yeah, and we'll have a j. Let me first create the array where we are storing everything. So let's call it pp, and we want to initialize the array with 1, right? Because every element at its own index is contributing to longest increase subsequence by 1. So array dot fill pp with 1. Yeah. Now I iterate, and I will also iterate from j equal to 0 to j equal to I. Okay, and j should be less than I. So if nums of j is less than nums of I, only then we'll update dp of I to maximum of whatever it was, comma, dp of j plus 1. And after this, or we can also do one thing, since we have to return the max thing, we can do 0 max dot max dp of I comma res, and this is equal to this, and I can return result. This is O of n square solution. I think they will not accept the O of n square solution. They are saying, can you come up with an algorithm that once in O of n log n times equal to 0? What is the issue? Why? Acha, sorry. Result should be initialized with 1. No. Okay. Let's look. O of n log n means binary search or something. Binary search is log n. What are the topics? Binary search, dynamic programming. Look at the list. Mm. And again, binary search came twice today. I think earlier also in one of the questions, binary search was there. Yes, medium, and I'm not very good at binary search, so I just noted down. I need to study binary search. Let me just note it down. Binary search for optimized approach. Again, binary search for optimized approach. I think this will give me clearly. Let me try submitting, but this will give clearly. Okay, this will not. This should not be clearly. Yeah, this will not be clearly. If you see uh, the the constraints, n is within 2500, so walk and square is not within any clearly, but in an interview, people will expect binary search, which I am not good at. Uh, this is hard. I hate dynamic. It's not a solution. Changing all the submissions. Wow. DP solution. All the hard talk. Okay. Again. So binary search. I'll have to study binary search. Okay. For now, let's move ahead with the next questions. Summarize with at most k different integers. You also do development as well as do study or do you do job. I am SQ2. Summarize with k different integers. Uh, I think this question recently came in daily challenges. I think I submitted it 2 days back. Yeah, July 2020, July 22. So 7 days back, this was a uh, what a daily challenge. Yes, yes, yes. I submitted it 2 days back. What is the question? Given an integer array. Wow, let's test it. What do you want to test? What do you want to test by? Given an integer array and an integer k, return the number of good subarrays. Good array is an array where the number of different integers in that array is exactly k. Okay, we have this subarray is found with exactly two different integers. All the have to see all the subarrays. Number of different integers in that array is exactly k. Okay. You just got to answer questions I asked, programming questions. See, even if I am unable to answer, I'll still be an IC2. I'll still be a SDE2, right? Why will I answer your questions? Yeah. Why are you testing me, Devansh? Okay. Uh, Given an integer array, minus an integer k, return the number of user arrays. Yeah. I have to figure out let's see, number of subarrays formed with exactly two different registers. Okay, ठीक है. If I start at this, I think I think this is sliding window. I believe. I Let me just try to do it. But in my eyes, you go down. No problem, buddy. No problem at all, Devansh. If you want to ask questions, you can. But yeah, anyways. Uh, yes, let me study. This is sliding window. I have to prepare the window first, and I'll also need a hash map for counting the frequency. Okay, so let me just prepare hash map. Okay, yeah. So what happens is we get one. Suppose we are at S0 R0. Okay, so let me just also visualize this thing in here. So right now we are at this position L. Let me just write this. This is not very good. So we are at this position. So L is equal to 0, R is equal to 0. Yeah, L 0, R 0. Add this. Okay. Now what we are trying to do is we will uh, okay, what we will do is we will add this number or the current index where we are at to we'll add this number to our map. Okay, so yeah, mp dot put uh, nums of r, comma, mp dot get or default nums of r. If we don't find it, 0 plus 1. Okay, now which means if I have my hash map somewhere here, empty, I have added 1. Okay, now I have a shrinking logic as well, but for now our window size is good. I have less than like I want number of different integers is exactly k. Okay, so okay, I need exactly k k integers, correct? Right now it is 1. Okay, okay, let's see. Basically we will not count it. We'll only count if it is. So let's have a result as well. Let's have a result as well. Result plus equal to if empty dot size is equal to 2, then we can increment, right? Or this is equal to yes 1, otherwise 0. You just have to share the number of those arrays. Okay, ठीक है. And yeah, R plus plus. Actually, uh, okay, so here what we can do is we can find out the uh, subarrays. Basically, we can try finding at most k integers, subarrays with at most k distinct integers, and subtract that with subarrays with at most k minus 1 distinct integers. Okay, that is the clue That is the core of this problem. Okay, because this will not work for us. So let's do one thing. Let's do one thing. Uh, Let me write the code to get at most k, and then we can just copy that code and use it as a function. Yeah. So L0, this entire thing. Let me just copy. Then let me just copy paste everything. Yeah. Okay. So we're adding number and while uh, empty dot size is greater than a, we'll have to shrink. We'll have to shrink. Okay. So if we have to shrink, then nums of L will shrink from the left. Wait, I have empty dot put nums of L, empty dot get nums, sorry, get nums of L -1. And if empty dot get nums of L is equal to 0, uh, we'll just remove nums of L. And here we will do L plus plus. And here result will be equal to S minus L. Sorry, R minus L plus 1. Yeah, yeah. So this is giving me at most k. And here what I have to simply do is I have to return at most k for nums comma k minus at most k nums comma k minus 1. Let's check. Or less than n. What is your question? Integer a is 200, integer b is 200, print a is equal to b. अरे यार, let me mark this. Let me know if I pass. Okay. Let me know if I pass in your test. First mission positive. This is a good question. So where is with k different integers? First mission positive. First mission positive. Okay. Okay. It is a hard problem. What is the question? In an unsorted integer array, nums return the smallest positive integer that is not present in nums. Okay, integer can be from this range. That return first missing positive, so unsorted integer array return the smallest positive integer that is not present in nums. Algorithm should run in O of n time and O of one auxiliary space. O of one, O of n time. Basically, in one pass, two pass, or in some X number of passes only, I won't have to figure out the solution. Numbers in the range 1, 2 are all in the array. So 0, 1, 2, 3. Okay, first missing positive. So 1, 2 is missing. Now 1 is missing here. Okay, 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 okay. Okay. So, so. That is not present in nums. Okay. Hmm. 1, 2, 0. So I have 0, 1, 2, 0, 1, 2. So 0 should be basically any if you try to sort it, like any number will be present at its index, right? Or yeah, so 0 should be at 0. You can swap. If I try to check this, we have 3, 4, minus 1, 1. So okay, okay. We are not concerned about 0, so our range of answer starts from 1. Okay, so what we are trying to achieve is that if we have 1, we should place it at index 0. If we have 2, we should place it at index 1. So whatever number we have, we should place it at index the number minus 1. Okay. What? How do you know this? Integer is an object, right? Hmm. Integer is an object, int is primitive. So integer equal to math tries compares reference. ठीक है कहाँ थे where were we yes so for yeah this is what we are trying to achieve okay which means we are trying to achieve this so 3 we come at 3 so we are trying to say that should 3 should be at index 2 correct yeah So if 3 is at index 2, 0, 1, 2, we have minus 1, so we swap. So we have minus 1, we have 4, here we come up with 3, and here 1 is 2. Okay, then, okay, then we have minus 1 here, so ignore it. We come to the next number, which is 4. So it should be at index 3. It should be at index 3. So we'll swap 4 to index 3, and whatever number was there is coming in here. Now minus 1 is 1. So 1 should get index 0. So we have 1 minus 1 equal. Okay, after this we are easily able to tell that what is missing is 2. Okay, yeah. So we can just let's just try to code it up. So we'll start we'll iterate across the array, and only if the width of I is greater than 0. Okay, what we will do is uh, wait, let's have I less than I. Okay, I starts with 0. If also I is greater than 0, only then we are concerned about whatever we are doing. So we are at 3. So current number is nums of I. Okay, nums of I, nums of I is 3, and according to us, it should be at index. It should be at index current minus 1, right? So 3 should be at 2. So what we try to do is we try to do one thing, and is equal to current nums of I is equal to whatever the stuff is at uh, wait. Whatever the stuff is at index, yeah, and we try to switch. Yeah. So here the swapping thing is taking place. We are swapping. So wait, current is 3. We want it to be at index 2. At now temp is equal to 3. Nums of I is what? I 0. So nums of 0 is nums of 0 is uh, um, P. So there we place nums of IDs, which is 2, 0, 1, 2, minus 1. So now the array becomes something like this one, this one. Yeah. So array becomes something like this, and nums of index is equal to 10. 10 plus 3. So yeah, okay. So the swapping will take place once we have done the swap. The only increment I, uh, we've done the swap. Okay, done the swap. For this, it's true. A is 100. I think values up to 100 are cached. That is why. For that, it will count as true. Uh, so there is a range where objects are cached. That is why it is coming true. So minus 128 to 127 integer Java caches some values, some lower values. That is why for a equal to 100, it's returning. So what do I do? If only it is greater than 0, else we simply do I plus plus. If it is greater than 0, also it should n. Okay. So if they are equal, we don't worry. We, we don't have to worry, and we can move ahead. Okay. So after this, I can simply just iterate through the array. If theta is not equal to I plus 1, I can return I plus 1. Otherwise, I return I plus 1. What is the issue? Compile error. I is already defined. Okay, no problem. ID, ID, ID. But this is also a good question. I mean, this list of questions is really nice. All of these are amazing questions. It can be asked in any interview, actually. 0 1 matrix. Okay, they have done first unique character, median of 1, 2, 3, 4, 5, 6, 7, 8. They've done 8 questions. They've done 8 questions. First unique character. Few were easy and two of them are managed to solve with the optimized approach. 5, 6. Still, we have done good number of questions. Uh, 0 1 matrix, given a matrix, return the return the nearest 0 for each cell. Okay. Okay, so let's continue tomorrow. Uh, let's see how many of these I'm able to do tomorrow during the day. If I'm able to do it, if I'm able to complete it, let's see. Otherwise, we'll continue on this list only. Okay. Um, any more questions? I am wrapping up. Let's see if there are any questions. I'll take up the questions. Hmm. Binary search, bit manipulation. These topics I find little tough. Actually, I should do that. Leetcode. I have a Leetcode disorder. This is a very interesting problem. I'll solve this now. I mean, this can be an LLD question as well. That is why that is why I skipped it right now, because I want to be very thorough with this thing. It can be LLD, it can be ESA, it can be anything. So it's a very interesting question. Seems like no more questions. No more questions. Any questions? Anything anyone wants to say? This I'll work on now. I mean, after wrapping up the stream. And yeah, I'll solve these questions tomorrow. Then I have this list, uh, GS list, a list of questions asked in gold marks class, which I'll try to solve. Let's see how many I'm able to solve. String compression. What is string compression? Acha, Leetcode. Okay, this is a question. I thought it is some topic. String compression. String compression. Okay, okay. So this okay. I'll solve this one as well. I thought this is some BSA topic which we should study, but no, that is a lead code question. So we need to solve this as well. This as well. Okay, okay. Um. All right. So I'm closing the stream. Thank you all. Bye bye. Bye. End stream.